Okay, so now let us look at some of the applications of the factor theorem. How do we use factor theorem while solving problems? Okay, so first question, find the value of k if x minus 1 is a factor of 4x cubed plus 3x square minus 4x plus k. Okay, so what have we seen in the factor theorem? The factor theorem says that if p of x is a polynomial of degree n greater than 1 and a is a real number, okay, so if x minus a is a factor of this p of x, p of a should be equal to 0. Okay, so here it is said that x minus 1 is a factor of the p of x. So if x minus 1 is a factor of p of x, p of a should be equal to 0, which means p of 1 must be equal to 0. So when I substitute p of 1, I get 4 into x cube plus 3 into 1 square minus 4 into 1 plus k. Now since x minus 1 is a factor, this whole thing must be equal to 0, that is 4 plus 3 minus 4 plus k should become 0. So for this part to become 0, k must take the value minus 3. So if x minus 1 is a factor of 4x cubed plus 3x square minus 4x plus k, then the value of k should be minus 3. Okay. So now let us look at factorizing a polynomial. Factorizing means we'll have to split it into individual factors. Okay. So since this is a quadratic polynomial or a second degree polynomial, we can write it as y minus a into y minus b, where this a and b are some numbers. So what our aim is to find out what are these two numbers. So when we multiply these, okay, so I get y square minus by minus ay plus ab. Okay, so which is y square minus a plus b times y plus ab. Okay, so you can see the constant number. Okay, or when we compare this, the constant part here is 6, that is a plus b here minus a plus b times y. This a plus b here is minus a plus b here is, or a plus b here is 5, ab here is 6. Okay, so we are looking for two numbers a and b, so that when we multiply them we get ab as 6. Okay, so the factors of 6 are 1, 2, 3 and 6. So the two numbers could be a could be 1, b could be 6, or a could be 2, b could be 3, because 2 into 3 will be 6. So we are not sure which is the correct values of a and b, but we know that it is definitely any of these, any two from these four numbers. So what do we do? So if the value of a is 1, okay, that is if it is y minus 1, then this y minus 1 is a factor of p of y. So if y minus 1 is a factor of p of y, that p of 1 must be equal to 0. But when we check whether p of 1 is equal to 0, we get p of 1 is equal to 2. Okay, that means y minus 1 is not a factor of p of y, that is a or b does not take the value 1. So now we check for 2. When we check for 2, we get 2 square minus 5 times 2 plus 6, we get 0. So from this we can conclude that y minus 2 is a factor of this p of y. So one part of this is y minus 2. Okay, so one part is y minus 2. Now we have to find out what is the second part. So we substitute the next third one. So p of 3 is also, we'll get it as 0. That means y minus 3 is also a factor. So thus we have found the two factors of this polynomial. So what can we say? Y square minus 5y plus 6 is y minus 2 into y minus 3. And these are the two factors of the polynomial, and this process is called factorization of the polynomial. Okay, so what have we done here? First we saw that it is a second degree polynomial. Okay, if since this is a second degree polynomial, the factors will be of the form y minus a into y minus b. If it was a third degree polynomial, it would be y minus a into y minus b into y minus c. Okay, there will be three factors. Since this is a second degree polynomial, there are two factors. Then we saw that upon expanding them, the constant term would be the whatever a and b that we have chosen, the constant term would be a into b. So in our polynomial, that constant term is 6. So we know that a into b must be 6. Okay, then we looked at the factors of 6. What are the possible ways we can write a b as 6? It could be 1 into 6 or 2 into 3. So for checking 1 into 6, so if a is 1, that is if y minus 1 is a factor, then p of 1 must be equal to 0. But we know that p of 1, we got the value as 2, so y minus 1 is not a factor. Then we substituted for 2 and 3, we got that y minus 2 is a factor, y minus 3 is a factor. So these are the two factors of the polynomial. Now let us look at another example, factorizing 6x square plus 17x plus 5. So again, we saw that for a polynomial of the form x square minus a plus b times x plus ab, okay, this is x minus a into x minus b. Okay, so here we have 6x square plus 17x plus 5. So what do? We take out the 6 from all these terms, that is we take out a common 6. Okay, all right, so we have 6 times x square plus 17 by 6x plus 5 by 6. Okay, now this polynomial inside this bracket is of this form. Okay, now what do we have to do? Whatever is in this bracket, we have to find out what are the factors of that polynomial inside the bracket. Now we have a plus b, and a plus b here is 5 by 6. So what are the factors of 5 by 6? So this is of the form 6 into x minus a into x minus b. So we are trying to find out what is this a and this b. So so we have seen that ab is 5 by 6. So the factors of 5 are 1 and 5. The factors of 6 are 1, 2, 3 and 6. So the possible combinations of AB are, I can take 1 by 1 and 5 by 6, or I can take minus 1 by 1 and minus 5 by 6. Okay, or else I can take, see, I am using a combination of all these numbers. Okay, I took 1 by 1 and 5 by 6. Okay, now I'm going to take 1 by 2. Okay, I'm going to take 1 by 2 and 5 by 3, because that will give me 5 by 6. Or I can take minus 1 by 2 and minus 5 by 3. Or I can take 1 by 3 and 5 by 2. So these are all possible combinations. Okay, so what do we have to do? We have the p of x here. We'll have to substitute all these values one by one inside p of x and find out which value becomes 0. Okay, so we start from p of 1 by 1. Next we check for p of minus 1 by 1. Okay, so the key idea is we should not leave out any factors. That is, we should not leave out any possible combinations because we might never know what is the correct factor. So please keep in mind not to leave out any of the possible factors. So we'll have to, so this is a time consuming method because we'll have to start from 1 by 1, x minus 1 by 1, 5 by 6, minus 5 by 6. So maybe the correct answer would be at the last one, maybe it would be the first one. So it is called a trial and error method because you be try, if we get an error we move to the next option. So it is called a trial and error method, and it is generally it takes a lot of time. But as we move, see, in this problem the first four options are wrong. So when we move to p of minus 1 by 3, we'll get p of minus 1 by 3 is 0 and p of minus 5 by 2 is 0. So if p of minus 1 by 3 is 0, what do we get? We get x minus minus 1 by 3 is a factor, that is x plus 1 by 3 is a factor. P of minus 5 by 2 is 0, so x minus minus 5 by 2 is equal to 0, that is x plus 5 by 2 is equal to 0. Okay, so p of x was 6 into x minus a times x minus b. So x minus a into x minus b here is x plus 1 by 3, x plus 5 by 2. So p of x is, we can write this as x plus 1 by 3 times x plus 5 by 2. So I am cross multiplying the denominator, okay, taking the common LCM. So I get 3x plus 1 by 3, next 2x plus 5 by 2. Okay, now I can cancel out because the denominators they become 6 and I have a numerator has 6 on top, so they will cancel out each other. Okay, and I'll get 3x plus 1 plus 3x plus 1 into 2x plus 5. So 6x square plus 17x plus 5 can be written as 3x plus 1 into 2x plus 5. Okay, so as we have seen, the uh, factor theorem method, that is in which we look at the factors, and we try them one by one. Okay, the factor theorem method, this actually takes a lot of time. It is a kind of time consuming method because we'll have to try and find out the error for all these, because sometimes maybe the first option might come as correct and we might be able to factorize it, but when there are more number of factors, it is kind of really hard for us to do or to try out all these possible options to find out the correct factors. So to save our time, there is a different method. It is called as the splitting the middle term method. So now let us look at the splitting the middle term method to factorize polynomials.